Okay. Hello, everybody. Welcome. Welcome to the Open Compute Advanced Cooling Solutions Engineering Workshop. My name is Caleb Lusk, and I'm with Rital. I'm one of the co-leads alongside Hamid Kihani from Facebook, representing the Bracken Power Project. It's my privilege to introduce the ACS leads today, and we have Jacob Na from Facebook leading the door heat exchanger. We have Michael Bergtold from Intel leading the cold plate. And last but not least, we have Ralph Brink from Asperitas leading Immersion. So for anyone new to our work stream, I want to speak a little bit about the project charter and just advanced cooling solutions. You know, what is advanced cooling solutions? Um, High performance computing has been using liquid cooling for many years, and these solutions have proven to be, cost effective and efficient at heat extraction. Um, with the growth of 5G, IoT, and VR, and CDN and latency issues and sensitive applications like that, uh, data centers are being constructed in regions just around the globe where cooling becomes challenging. In these cases, really the liquid cooling and specifically warm water cooling becomes an effective alternative for heat extraction. So listed here are both the activities and the project focus really that I'm showing. And in scope activities for all these projects are things like physical fluid properties, operating conditions, parameters, metrology of heat extraction performance, um, IT gear optimization, and determination of wetted materials, and including tests and best practices. Just for a quick visual, we wanted to kind of show the community just what the structure looks like for this initiative. Uh, the ACS projects are with the Rack and Power Project group, and you can also see there's links now that have grown from the harmonization efforts to both DCF and ACF now. So again, welcome everybody to the ACS workshop today. And with that, I'd like to go ahead and hand it off to Jacob.
Thank you, Sarah. So I just want to give a little bit of introduction of what's going on and what's the project scope of the door heat exchanger group. So the door heat exchanger group is we are currently looking into the current scope of the activity on the door exchanger is looking into design specifications to the open rack only at this point. So this is including the physical and interfaces specification and serviceability and regulations around the door exchangers. That's including the form factor of the door exchanger, as well as the how this door will be mounted on the open rack um, um, spaces, and also looking into what is the operational conditions and what is the cooling capability, as well as the quality and reliability around the door exchanger specifications. We are also looking into some of the methodology of how methodology of the heat exchanger performance, understanding how this door heat exchanger can be um, dissipating the heat from the system and to the data center within the air cooling and the facility water site, and also looking into what is the variety of the application of the door exchanger, not only looking at the traditional door exchanger type of solution, but also looking into a variety of the data center applications. So what's happening here currently? We are currently going through the OCP incubation community approval for door exchanger specifications, which just happened about a week ago. we are currently looking into another specification around the application of the Doit exchanger incoming soon. To speak to that, I'll hand it to Ralph for the immersion.
I think Michael's first.
Oh, okay.
Yep, actually, we'll go to Michael next.
Okay, sorry.
Thanks,
Mike.
Jacob.
No, thanks. All right, so for the coplate, quick overview on the sub-project. So what we're trying to do with the coplate sub-project is we're trying to generate specifications and some standards without stifling innovation, preventing innovation. So different things that we've completed so far as contributions are the ACS coplate requirements document. We finished that sometime last year. There's a manual couplings and hoses best practices, which we just finished, that just got approved. Speaking of the approval process, the universal quick disconnect specification was just reviewed. Will hopefully be approved soon. Other documents that are in the works, I'm actually working on a leak detection and mitigation white paper. I got a presentation on that later on today. As well as there is also going to be a blind maze interface group. So those are the things that we have in the works. So now next, I believe, is immersion with Ralph.
Awesome. Take it away, Ralph.
Yep, thank you very much, Michael and Caleb. So yeah, the Immersion group is also a very active group at the moment. There are several approved contributions. In 2019, you all might remember the launch of the OCP Immersion Requirement Specification, which is a document outlining a minimum level that immersion technologies and immersion solutions should comply with, and also provides for a set of guidelines on developing standards for immersion. There's been several specs regarding tooling and features related to immersion. A fan simulator, which is a helpful little tool, but also an open cassette spec, which is a starting point of several server developments within the immersion space. And right now, today, we're announcing the launch of the white paper design guidelines for immersion optimized IT equipment, which is going to be submitted any day now to the incubation committee. The current projects that we're working on are focused on material compatibility and a revision of the immersion requirements. The material and liquid compatibility is a focus group within the immersion workstream, within the immersion community. It's also a very active one. There's several liquid vendors, liquid providers active, and also immersion solution providers, as well as server and component manufacturers who have joined into that workstream. And that workstream is focused on creating a frame of reference for the industry regarding what kind of liquids to comply with, or how you can achieve a proper material compatibility when developing and designing for the purpose of immersing IT equipment. And that the whole focus of that project is also to create and generate industry standards to a level where immersion can be much more widely adopted, also in terms of IT manufacturing and IT design. The other project is the revision of the immersion requirements, which I'm leading myself, and that is going to be focused on updating the original immersion requirements document that was approved in 2019. The first meeting is going to start for that in the next month. That was supposed to happen today, but there was something else on the calendar. The contact for the material liquid compatibility workstream are Jamil Shah and Eduardo D'Azevedo from Shell. So 3M and Shell, two of the main liquid providers in the industry, are leading that effort at the moment. Back to you, Caleb.
Awesome. Hey, thanks. Thanks, Jacob and Michael and Rolf for those overviews. I wanted to do just a kind of a quick recap of kind of last year's Rack and Power and ACS workshop. Now, most of you will remember our time together last year out in California, and My, how things have changed. um, but no, joking aside, you know, we had a lot of good collaboration last year during that workshop. If you recall, there was good dialogue around the ASHRAE terminology relating to OCP. There was open conversations with the requirement docs where the groups discussed, like we've said, the things like supply pressures and fluid quality and wetted materials and fluid metrology. Um, we discussed the concept just last year of the V3 open rack, as well as bus bar plating. So, excuse me, that was that was a year ago. And, when we fast forward to today, you can see those, the product of those discussions now. I believe there's been 5 contributions related to ACS just over the past 12 months. The requirements documents, best practices on manual couplings and hoses, all the way to the open cassette design for immersion. So, there's also the harmonization between the ACS and the DCF continues to grow. And from that alignment, really, the Advanced Cooling Facilities Project came on board. So truly great things are happening within the project, as you guys can see. So I will actually go ahead and flip it back over to you, Ralph.
Yeah, sure. Oh boy, do we have an exciting day today, right? So, well, there's a couple of great sessions on the schedule. This schedule has been assembled by the joint heads here of the ACS group. So, and there is a logic to the schedule for today, and we're setting the scene with the very first session by Andy Young from the University of Leeds in the UK. Which is going to be focused on the thermal journey of the chip to the facility infrastructure. So as we are adopting liquid technologies across the industry, when decisions are made for facility design purposes, it now becomes relevant to consider what kind of chips you're going to be using in the next couple of years, right? So, because that determines on how you're going to implement your cooling strategies and how you're going to be working with further optimization beyond air. Following that is the presentation by Jessica Goblin from Intel, who has been one of the important influences in the community white paper, which is focused on design guidelines for immersion optimized IT equipment. And that is a white paper that hopefully is going to help out greatly in across the industry, but of course, especially in the OCP work streams. When we're starting to develop IT equipment for the purpose of immersion. This is the material compatibility work group, focus group, is a direct result from this white paper as well. So you can also already see the continuation from there. Following that session is a session that is actually done by myself, but in this case, not as the OCP track lead, but as Rolf Brink from Asperitas. Because I will be showing how the design guidelines for immersion optimized IT equipment are actually implemented in reality, right? So this is something that Asperitas is working on, and I'll be showing practical results of an embedded process that is focused on optimizing IT equipment for immersion. And finally, and the first track of the agenda for today is the introduction of the OCP material compatibility efforts for immersion cooling by Jamil Shah. And he will be managing a panel consisting of Usama Liza from Microsoft, Yin Yang from Intel, Eduardo D'azevedo from Shell, Philip Tuma from 3M, and Rob Curtis from Dell. So that's gonna be an exciting start of the day at the very least. Michael, would you like to take over from here?
Yeah, for the co-play agenda, the next slide. Thank you. So I think I mentioned earlier, I'll be starting off with a presentation on Weta materials. This is based on the Intel's put together and we're sharing. Next, Glenn will be going over the ORV blind mate liquid cooling interfaces. And continuing on with the ORV blind mate, we will then have Timothy coming in and talk about quick connectors. After Timothy, we've got Scott coming in to talk about the blind mate manifolds. And then we have Chris Lee talking about blind mate liquid cooling and IT gear. After that, Friendly Face is back again with me coming and talking about leak detection and intervention. Again, that's a project that we've been working on. Should be releasing paper end of this year, early next year. And I will be talking about leak detection and intervention then. And they'll be rounding out the cold plate section with Jeff and team going after manual coupling of hoses best practice. That's the white paper that's just been approved. All right, and next slide.
All right, thank you, Michael. So for agenda for authority exchangers, I think there is the two major things around on the door heat exchanger. Number one is the ACS door heat exchanger updates. So this is about the specification updates around the ACS door heat exchanger group. Number two is the RPU update. So RPU is a redundant pump unit. And this is the mainly for the applications for how the door exchanger can be utilized within the air cooling data center by optimizing, modifying the CDU unit. So this is pretty much the CDU, optimized CDU towards the air facility data center, and then the specification around it. And then there's three harmonizations happening in the door exchanger groups. So ACS temperature requirement and management different thermal environments in the facility. This is run by Dell's and the other OCP community. And also the challenges experienced with the liquid cooling deployment. As we all know, the facility there are many facility designs around the world and around the United States, and there's certainly different challenges that we are facing with the different facility. So we would like to understand what type of challenges we are facing with the liquid cooling deployment, and this is going to be run by multi community groups of discussion and harmonizing it. Finally, it's a redfish for the dummy and redfish for cooling. I think the cooling solution is certainly a need for a certain thermal management type of solution. So we would like to leverage the redfish as a part of the thermal management to monitor and control the cooling solutions around the door exchanger as well as the other ACS groups. Speak to that. Next slide.
Actually, the harmonization presentation, ACS temperature requirements, has been changed in name from different thermal requirements, friend or foe, and it's going to be focused on dealing with these different temperatures within a single cooling loop within a facility. Just wanted to elaborate on that.
Cool, awesome. Thank you. Thank you, Rolf. So call to actions, we want to have everyone to join and contribute to the ACS. So as we mentioned, there's three in ACS groups. We focusing on immersion cooling, cold plate, and a door heat exchanger. We would like to have all the community can be collaborating on the specification and the white papers towards we can standardizing all these solutions with the community members. I think this is very important for us to collaborating to start building the more ecosystem around the OCP and around the solutions. And we would like to also leverage the knowledge to bring it up to the OCP from all the community members who have been working on liquid cooling or interested on the liquid cooling that help us to build the more knowledgeable and standard solutions around the liquid cooling in the OCP. So there's more information on the slides. There's a ACS wiki and a mailing list I'd like to call out an action that everyone who's interested in, please check this website and check this wiki and start collaborating. Thank you.
Perfect. Excuse me. Yeah, perfect. There's a good lineup for today. I hope everybody has, in the community has time to really find the track that they're really interested in, if not all the tracks, and really dig in. But it's a lot of good stuff out there, and I know Redfish for Dummies, that's going to be one that I'm going to attend for sure. So understand more about that even myself. So again, thanks to everybody that is joining and participating today, and really thanks Michael and Rolf and Jacob for all of your dedication and hard work too, throughout the projects and throughout the day, really. So with that, I believe we are actually finished. We're done a little early. So thanks again, everybody, and we'll see you guys soon.
Do we want to invite some questions from the audience?
We certainly can.
Any?
Yep, we certainly can. If there are any questions that are out there, specific to maybe the agendas that are coming up, we can certainly address those. You see here, I don't know if Michael Schill, if there are any that have come through.
Somebody is coming into the session to speak.
Everyone, during this open discussion time, if you would like to ask a question of the speakers live via audio, you can click the Join Now button at the bottom of the video player. That'll put you into the Zoom, and you can join us to ask a few questions.
Amba Prasad, you've joined the Zoom call, but you're still on mute. If you want to ask a question, you have to unmute yourself. It's on the left bottom corner of the application.
Michael, do they also have the availability to chat questions if they would not like to be live?
Absolutely. So folks, if you want to chat a question, you can do that either in the Etherpad at the bottom of your screen, or you can do that in the chat column to the right of the screen. And for the speakers, remember, we are operating off of a few second delay here for the live stream. So folks may be asking questions or about to join, and we just don't see them yet.
Okay. Yep. Good enough.
Yeah, you thought time travel didn't exist. We're actually living in the past here.
Yeah,
or in the future,
exactly.
I should say. Yeah, we're in the future. So, which sessions are you gonna be most interested in, Caleb, for today?
There's a few different ones that I'm going to be jumping into. The door heat exchanger one, with Jacob, the one with Dale. I want to jump into that one for sure. I'm looking forward to that dialogue. He's an excellent presenter, but he's very knowledgeable and brings a lot of good information to the table. So yeah, and like I said, the also interested in the redfish one, and I really like the title, Redfish for Dummies.
Very good.
Yeah.
Dr. John Summers also has a very interesting session, by the way. It's a first of its kind, where it's going to be focused on all the things that may not be as pretty with liquid cooling, just to make sure that we're all prepared for potential challenges arising.
That is, yeah.
I know John personally very well, and he is probably one of the people who's been involved in liquid cooling the longest in terms of academics, and he's seen them all, and he's been involved with every single one of us. So that's going to be interesting.
How about you?
I'm actually also looking forward to engagement with the server groups, but for sure that the sessions by Dale and John are of interest. But I think I'm most curious about the upcoming session right after this slot, which is going to be of the thermal journey from the chip to the facility by Andy Young. He's got a great view on the ecosystem and how these technologies work together, and what happens when you make a choice somewhere in your IT spec, how that results in different ways of designing your facility. So that's going to be of interest as well.
Yeah,
that's what
that
I'm
would
really
be a good
looking
one
forward
as well. Yep.
And of course the optimization of server systems, right? I mean, come on.
Of course.
I have to promote the immersion track here.
Hey, I have a quick question, guys.
Yes.
Hey, Bill.
Hey, good morning, good afternoon. Hey, Rolf and I were in a earlier server track, and it was talking about a spec development for a general purpose enterprise class server, and how they are working on trying to harmonize the availability of a multi-sourced server board that could go into a 1U or 2U enclosure. So my question is, if you have a product like that, what type of changes would you recommend for that particular server board or server itself to design it for immersion? What are the types of changes that you would recommend or that you would need to go through?
I really love that question, Bill, because that's where we've got 2 sessions dedicated to answering that question. But in short, focus is first of all material compatibility. That is one of the key elements that the focus group, but also the immersion community is working on. But second of all, there's all sorts of layout choices. One of the fundamental differences with immersion, at least with open bath immersion, right, is the fact that you have only one side to access. So a lot of server designs are working with one end of the server having hard drives, the other side of the server working with blades. Well, you don't have that freedom anymore with immersion. You only got one side, which is in a way similar to the OCP ecosystem, right? As in working with backplanes for power and networking. So that is something that influences the design. So you can position. You're going to be having some different considerations when you're thinking about where I'm going to place my CPUs and a memory, and where I'm going to put the components that actually can tolerate higher heat. You might want to benefit from that by organizing your equipment in such a way that you can start generating heat that's one of the sustainability angles that you can have with the server design. But when it comes to performance, there are similar considerations. And there's a whole bunch of guidelines that we've prepared and put down in a white paper. And that's going to be presented in 2 sessions from now.
Okay, I'll
have you there.
Yeah. So you mentioned you only have availability on one side. So I think what you're referring to is in a normal enclosure, you can have the I/O out the front and the back. And so when you put that into an immersion take, I'm assuming that I/O is out the top in this case, at the top of the tank.
Exactly. It's things like that, but also servicing accessibility, right? So if you got something that you want to have hot swappable, and you have that positioned on the rear side of a chassis, and you then immerse it, there's no way you're going to get to the rear side, because then you have to dive underneath the server, underneath the liquid surface to reach that end of the server, unless you want to pull it out. But then there's no use in having it hot swappable, because then you have to switch it off first. These kind of considerations And that's only one of the dozens and dozens of considerations that we've outlined in both mechanical design considerations as well as thermal design considerations and fluid optimization for materials, but also things like heat sinks. Liquid offers a lot of benefits right now. Anything that has been designed for air usually can work fine in liquid, but what if you were to optimize the design for liquid? Then you can gain some serious benefits from utilizing and designing for liquid, and that capability will start unlocking a whole new way of dealing with server performance or platform flexibility.
I suspect that like airflow, when you put heat sinks behind each other, that you get reduced, thermal conduction, and I suspect that's the same in an immersion tank.
Yeah, you can. So there are, again, also there's different ways of looking at the same thing. So yeah, in principle, a couple of baseline design parameters will be similar. Like if you want to make sure that the CPUs are operating at the same temperature, yeah, you can utilize the thermal shadowing and you can optimize it to achieve that effect, right? And but there can be, you may not need to because you're working with liquid, which may be much more suitable and much more efficient in getting rid of the heat. So it might be less of a concern, whereas in other applications it might be a bigger concern, which is not. So yeah, in essence, there is some of the basics is very similar, but there is an additional potential which can be gained.
Yeah, thinking about the differences in front I/O versus rear, I think during the server design process, having done that for 20 years or so, it's pretty easy to take signals that would normally drive LEDs or reset buttons or power buttons and that are typically, put on the front of a server. It would be real easy to have a second set of traces that go to the back to a connector. So, if you were going to put that board into an immersion system, you would have another set of, header connectors you could connect to. So if we kind of capture these ideas and desired features, recommendations early on, I think that you can design, make those design considerations during your board design phase. So I think it's, I'm actually looking forward to that session this afternoon or in a couple hours.
Yeah, so I'm actually doing the same presentation both in the ACS track here and the server track. So in the server track, I will do a half session length. So it will be a 10-minute presentation, but in this session, I will have the 25-minute talk where I'm going really in depth in certain design considerations and how we've done that with several different OEMs. As in, right, this is what we're working on with the community, so let's make sure that these OEMs are ready to run with that as well.
So just one other comment, if you missed my presentation yesterday, I talked about our 2021 priorities, and as an organization, scale out of advanced cooling solutions was actually a high priority for the entire organization, as prioritized and ranked by our incubation committee. So they see the opportunity and the challenges ahead. The opportunity being, to enable deployment of high performance and high, power demand systems, but also the challenge in trying to ready these facilities to be able to accept it. So the work that's going on in this group, as well as in our data center facilities group, to enable the facility itself, is very important. And I think that's reflected in our 2021 priorities.
Yeah, and I would would echo just that, Bill, because you can see so much of the activities right within the whole ACS group, that that's supporting that effort, and you can see that that initiative.
Yeah,
for sure.
there's a new group that was formed under data center facilities for I think it's ACF, Advanced Cooling Facilities. Really
Right.
looking at that harmonization of the on the facility side. What is the what are the types of equipment that's needed? What are the performance metrics for warm water return and so on? And how do we enable more facilities around the globe, and particularly facilities that are owned by colo operators, that would allow liquid cooled racks to be installed. And if you look at the map, it's pretty obvious that we're going to have easily have 50 kilowatt racks. Well, we do today, there's no question about it. But we're going to see the need to put 50 kilowatt racks into existing colo facilities, and you don't want to over design and strand those resources by putting a bunch of extra cooling in, air cooling. So the best way to do it is to really design a portion of your facility to accept liquid cooling, and have the chillers and the cooling towers to accept that warm water loop. So it makes it more cost effective for the operators, and actually allows the facilities to scale, because you can bring some of that equipment online, at different phases, and still operate your data center at traditional air cooling. So.
Yeah, exactly. And I was going to say too, I mean, we don't necessarily we didn't really set this up as a panel. It was more just an introduction, right, to the day for the ACS group. But why don't we, Ralph, I like where you were going with that. With Bill, we probably can see what's on your agenda from what you just said, but why don't we take maybe 2 minutes, just a couple minutes each person, and Bill, we'll start with you and go around. What's on your agenda from the ACS, and maybe tee up, for the community, what they may want to look into that they didn't think about already after looking through the agenda today.
You wanted to start with me.
We don't have to. We don't.
Well, no, that's fine. I talked about the priority. There was one other priority, and it's related to this. There was several, but security of the facility, and particularly the control systems. And so one of the things that I think that this group should look at is, or at least be cognizant of, is as we put together a community of experts on control system security, that think about on the immersion tank, on the rear door heat exchangers, on liquid cooling, what types of control systems are being used, and how is those control systems secured. So there's a physical, in some cases there's a level of physical security, and then obviously the same type of software security, root of trust, firmware updates, things like that need to be taken into effect. We also prioritized as an organization the need for co-design of hardware and software, bringing hardware and software expertise together to solve the the problem of delivering AI and machine learning type of solutions. So this is basically as that grows, that's going to put more pressure on the cooling systems, as we are able to figure out how to deliver a lot more performance. That usually means a lot more power. So it just highlights the need for this type of solution.
Yeah. Good. Well, cool. We can definitely see what's on your mind. Michael, maybe what's from the agenda standpoint, anything that you plan on attending outside of your own project that has an interest to you?
Me, I'm definitely planning on attending the immersion tracks that are next. I guess people working on it. We've been talking a lot about that lately. And definitely some of the discussions towards the end of the day, the open discussions, really looking forward to those. Yeah.
Good, good, cool. Okay. Jacob, maybe anything from your side, what you're planning to attend throughout today, outside of obviously your heat exchanger stuff.
Yeah, so I was actually thinking outside of the heat exchangers type. I'm quite interested in looking into a little more detail on immersion cooling, what the love, and also the HPC updates, just to understand what's going on in the HPC side and how they're going to be linked to the liquid cooling need.
Hmm.
And also interesting to know like how how immersion cooling on the rough is going to be presenting it. So yeah, I'll be quite interesting to join that.
Good stuff.
Yeah, a lot
Good
of
stuff.
stuff, a lot of good stuff.
Definitely a good lineup for today. Ralph, maybe I know you talked about a few things you were going to be joining too outside of immersion, but what about you?
Yeah, so like I mentioned, obviously I'm going to be involved in chairing the tracks here as well and supporting the community here in this lineup. But yeah, I'm going to be very interested and very keen on seeing what's happening in the Rec and Power in general, Rec and Power group, new rec specifications, or at least the direction that you guys are taking there. But yeah, one of the things you've noticed that also with the comments from Bill, I think the next chapter that we're going to be closely involved in, especially with the authors of the white paper that we're now presenting as well, it's going to be alignment with the server groups. So we want to make sure that all the server developments are getting immersion in mind, and that we are going to be able to make sure that OEMs and manufacturers start taking immersion into consideration when designing their equipment, right? So I'm very curious to see where it's going. I've heard a lot about new chips that are going to do 700, even 1,000 watts. That's going to be exciting work, exciting stuff for all of us, especially in ACS, right? So that's
absolutely.
this is where we're coming from. Yeah, I'm afraid I'm going to be all over the place, Caleb.
That's perfect. That's perfect.